So a little bit of imaginary or complex numbers, a little bit of radical fun. For I to the ninth, if you haven't seen this recently, so you've got I squared is equal to -1, I cubed, well, you get I cubed from taking the previous line and multiplying both sides by I. That way this side becomes I cubed, and the result is it equals -I. Then, in order to get I to the fourth, you could multiply both sides of this one by I. So I to the fourth is equal to the negative of I squared, but over here we saw that I squared is equal to -1. So if you've got the negative of that, two negatives make a positive, it makes it a positive one. And then if you've got I to the fifth, well, multiply this one both sides by I, and it's going to be I. And then the whole process just repeats. It goes I, -1, -I, 1. I, -1, -I, 1. I, -1, etc., etc. So let's see, here's the first, second, third, fourth, fifth. This is the 6th, 7th, 8th, 9th. Whew! So there's one way you could do it. Or the faster way is, because there's only 4 possible answers, I, -1, -I, and +1, then they go in blocks of 4. I, -1, -I, 1. I, etc., etc. So if you look at it as blocks of 4, then basically you just have to say, okay, how many blocks of 4 do I have? And then, how many do I have after that? Or in other words, if you have 9 and you're dividing it into blocks of 4, so I have 9 numbers in the list here, and I'm dividing it into blocks of 4, so 4 divides into 9 2 times, good old division. And then what remains, remember long division? I learned it in 3rd grade. I think most people do. Anyway, what remains is what you need. So it says I've got 2 blocks of 4, and the remainder, 1. So that means that I to the 9 is the same as I to the 1. So if, for example, it was, how much is I to the 103? You take 103, divide by 4. It will go 25 times, because that's going to be 100. The remainder is 3, so you just go to the 3rd one in the list. There it is. So I to the 103 is the same as I to the 3, which is equal to -I. So you just need the remainder after you divide by 4. Well, next up, what I could do is, there's a couple of ways to do this. One is, because these are both cube roots, I could combine them as one cube root, and since this is multiplying, this is multiplying. That works with multiplication and division, but not with addition and subtraction. So you can make it one cube root, and then that's going to be the cube root of a to the 11, and then just do the dividing idea. 3 divides into 11, let's see, it's 3 times. So that means a cubed on the outside. And if I had 3 of them, 3 times 3 is 9, so the remainder is 2. So 2 of them remain inside. For this one, this needs to be simplified and put into standard form. In order to do that, you use what's called the conjugate. So instead of 2 plus 5i, we're going to multiply the top and bottom by 2 minus 5i. You have to multiply the top and the bottom by the same thing. And that is called using the conjugate. So On the top, for the moment, don't multiply it out, just put it in parentheses. On the bottom, start multiplying it out. So we would have 2 times 2 is 4. Notice that the middle terms are going to cancel. This, when you multiply these two, that's going to be a positive 10i. When you multiply the first one and the last one, that's going to be negative 10i. They cancel each other out. That always happens with the conjugate. Part of the reason we're using the conjugate. Then the last one times the last one is going to be negative 25i squared. But then you may remember that I squared is negative 1. So if this is a negative 1 multiplied with this, now makes it a positive 25. So a positive 25 and a positive 4 is a positive 29. Back over here, I said not to multiply it out yet, just in case that 7 could somehow reduce this. In this case, no. If it was a 28, it would have, but with 29, no. So go ahead and multiply this out now. 7 times 2 and 7 times negative 5 is negative 35i. And then to put it in standard form, you write the real number part is 14 over 29 minus 35 over 29 for the I part. So you just separate it as 14 over 29 and negative 35 over 29, and then attach the I to that fraction. What is the square root of the square root? Do they cancel each other out? No. The square root and a square would cancel each other out, but square root of square root? Well, what we could do is say, for this square root right here, the inside one, square root means the 1/2 power. And all of that is inside another 1/2 power. Then when you have a power raised to a power, you multiply. So a half times a half means a quarter. You could leave it like that, or you could say or, that means it's the 4th root of x.